Enjoy a fascinating journey through one of the most prestigious science careers in Western Australia with Professor Lyn Beazley, former Chief Scientist of WA. Lyn shares key moments of serendipity from earlier in her life that set her on the trajectory to where she is today. Lyn also modestly tells of how her weekend research project played a key foundational role in the development of the field of neuroplasticity, which is how the brain has the ability to change continuously throughout an individual's life. And this is a key foundation of the whole business of self-development. We go deep on what is the actual scientific methodology, how to build a career in science, and the state of science in WA, and other super interesting topics that include the Square Kilometre Array radio telescope project up in Murchison, shark repelling stripes on wetsuits, and much, much more. During her time as Chief Scientist of Western Australia, Lyn's key ethos was do science, translate science, and communicate science. And it is exactly this reason as to why this is a truly approachable and fascinating conversation with such a wonderful and curious lady. So enjoy Lyn. Hello and welcome back to WA Real. I'm your host, Bryn. Today my guest is Lyn Beazley. Lyn, welcome to the show.
Honoured to be here.
Thank you very much. So one of the questions I always ask my guests at the start is how they came to be in Western Australia. I understand that you came here in 1976.
That's right. For 2 years.
For 2 years.
Longest 2 years of my life.
You were supposed to be here for 2 years.
Well, that was the initial job, yes.
Right. And tell me how you came here.
Okay, well, you can tell by my voice I'm not Australian. I'm born in Britain, in a place with probably one of the worst names on the planet, Gravesend.
Yes.
Luckily, managed to go from there to uni, studied, and so I find myself by 1970, having met a wonderful partner. We're still together. Our first baby was born in 2000, about 4 years later, so that would be 1975, and by then we're living in Edinburgh. I have a PhD in neuroscience, a very new discipline, and I want to stay in research because I've really enjoyed it, but I also think that it would fit in pretty well with being a parent and flexibility to sort of travel anywhere in the world. My husband by then had qualified in medicine, and we looked at ourselves and said we always saw ourselves as sort of people who travelled a lot, explored a lot, yet there we were about to settle into a very nice house that we'd done up in Edinburgh, that we bought very cheaply and spent a lot of time doing up before all these shows came on the TV on how to do it. I wish I'd seen some. And we have a one-year-old daughter, and we thought, well, if we don't see something in the world now, we probably won't. And so we looked around. We wanted to be in an English-speaking location. I guess for both of us that was going to be easier. I had worked in Canada. Richard had worked in the US briefly. Didn't want to particularly practice medicine under their system. Australia was an alternative. We looked around. We found jobs that we were offered here in Western Australia. We talked to friends who had moved from Edinburgh who said it was a terrific place. We took a deep breath and we did it.
Right. What were your first impressions coming here?
Well, I'd expected a desert, so I was amazed to discover how green it was, to discover it was a biodiversity hotspot. I had read zoology, so I thought I knew a little bit about the biology of the planet, but I had absolutely no idea about Western Australia, and that was an absolute joy to discover animals and plants I'd never seen before. It was very nice to live in a climate that was warmer, having lived in Edinburgh for 10 years and had cold hands, and cold feet for 6 months of the year. And how friendly people were. So we came in September, and by Christmas we had so many invitations to spend Christmas with different families that we in fact went down south and we spent the week in the Parongarups, which was delightful, and we did it so we didn't have to offend anyone by accepting some invitations and not others. And it
English.
struck me that if we'd been in Edinburgh, it would have taken years before people invited us in the same way. So it was a joy. And the other thing was, as a scientist, realizing that here people were very genuine in wanting to share and work together. And so in Britain, it had been a little bit, well, if you want to use a certain type of microscope, there'll be one round the corner. But here, there'd be one, and there wouldn't be another one for 2,000 kilometres. So I'm going to share what I have.
Right.
And that was hugely positive for me too.
Yes. So the remoteness
actually works.
promoted
Yes.
the
Yes.
sharing. How have you seen Western Australia change?
Amazingly. Well, let's try. Much more cosmopolitan, much better food, much bigger selection,
Yes.
not the two standard cheeses anymore, and you'd have to search for a real deli as opposed to a corner shop. The arts are hugely better than they ever were. We now have a world-class symphony orchestra. We're subscription members. We go every single time we can. The opera and the ballet and the theatre are so much better than they ever were. What else has changed? It's got a lot busier, got a lot bigger. Somebody said to me that they were living in Tuart Hill, and I thought that was the outer suburbs. Now it's inner.
Yes.
What else has changed? I think a feeling of sort of freedom, and we're growing into our skin now is the way I see it. Public transport is really good. I had a visitor from Cambridge recently in the UK, and he just couldn't believe the quality of our public transport, how good it is, how frequent it is, how cheap it is, how clean it is. That's the other thing. Everything here is, not only do we have the beautiful river and King's Park, and everything's close enough so you don't have to drive huge distances, but the other thing is the air is clean. You can swim in the river, you can swim in the ocean. The air you breathe feels clean. Litter-wise, we moan about it, but gosh, we are so clean compared to most places in the world.
Yes.
And that freshness and I guess joy of living. I think we, if you dig down, West Australians are, we're pretty glad we're West Australian.
Yes. Yeah.
And I'm one of them. How good is that?
I know. It's kind of why I asked the question at the start. Because I've been here for 9 years and I feel quite proud to be here. Really.
Good.
Yeah, certainly in the short period of time I've been here, I've seen it grow. But the cleanness that you talk about, when I go back to the UK and go and see my parents,
It's grimy.
just, just the air quality, you can just tell.
Not everywhere, but
last year when I went, I had this really unsettled feeling after a week, and I couldn't understand what it was. And then I worked it out because I hadn't been in the ocean for a week.
Yes, I find I have to be near the ocean, and I guess the other thing is, and this is sort of one of my scientific interests, of course, but how bright the light is here. And I think that has a very strong effect on all our body rhythms and the way we work.
It's interesting.
Because we have one of the clearest skies and the brightest light, and you really do appreciate that.
Yes, very much so. So you've had a very distinguished career in science.
I've been very fortunate.
You were chief scientist of Western Australia for a period of time.
Yeah.
You had numerous awards, Order of Australia, Women's Hall of Fame for Western Australia, and the Science Hall of Fame. It goes on and on and on.
Been around a while.
It's always interesting to research a guest when they have their own Wikipedia page. That makes life a bit easier.
I didn't write it.
No,
a friend did.
But where does the focus on science come from in Lyn's story?
For me?
Yes.
Okay. I think I always loved nature, and I was lucky enough to spend quite a lot of my school holidays with an aunt and uncle who didn't have kids of their own on what we would now call a marina. We called it a yacht station in those days back in Britain. And so I mucked about in boats. I can remember getting together a collection of all the crabs that I could find, dead ones, and lining them up, and I must have been 8 or 9 or something, and trying to work out, well, do I put them together by size or what they look like, or where I found them. And so I guess that was me sort of trying to put some logic around the world. And in Britain, they had this thing called the 11 plus exam. Oh dear, some of your people listening to this will go, oh no. So aged 11, you took this exam, and if you passed, you went to a grammar school, and if you didn't, you went to the secondary modern. And it was very difficult to do anything else. If you were a boy, you could go to a technical college, but girls didn't do technical colleges in those days.
Right.
It was very hierarchical. And I was initially told I'd failed the 11 plus. And then at the very last minute, they asked me in for an interview. And I somehow scraped through that and got into grammar school. And that's one of the big drivers I have now for supporting all young people. Because if I hadn't passed that exam, my life would probably be very different indeed. So we had a teacher who took us on an excursion, and she took us to Charles Darwin's house just outside London. And I looked through his microscope. Probably it's now in a case and locked away. But the very nice man, who to me looked ancient, was probably all of about 35, who was in charge of this his house. It was still set up as a science centre, and I looked through his microscope at his specimens. I actually looked at carnivorous plants. They could well have come from WA now I think about it, because we're the carnivorous plant centre for the universe, for the planet. And I just thought, I want to be a biologist. And so I did it at school. I managed to crack a spot at uni, and off it went. So that was it, I guess.
Yeah. Was there any particular impact that you wanted to have, or was it just
curiosity? No, I
like?
didn't think I would. It was totally curiosity driven. And I went to Oxford to do botany, but we had a joint first year course with zoologists, agriculture students, forestry students, geology students. It was a wonderful foundation year. And so I'd seen a range of science. And then I started on the second year, which was to study botany itself. And I lasted in that course about 6 weeks. And botany has been transformed now. A lot of biochemistry on how plants convert light into sources of energy we can eat, sugars and the like. Also, with DNA, you can now classify plants a lot better than you could before. So it had come of age. But what I was exposed to, and probably it was not the full range, but it was the very conservative, old-fashioned biology of just classifying things. And I thought there has to be more for me in a degree than this. And I switched across to zoology, because basically they had gorgeous photos of the Serengeti National Park and penguins in Antarctica. They had a Nobel Prize winner teaching there, and I just thought this sounded... And also thought I might be able to get a job better if I knew a bit about animals. Heaven knows why. And then, as I was coming to the end of my degree, I was going to go off and do a PhD on paleontology, studying fossils in London, with a very well-known biologist, a guy called J.Z. Young. Anyway, I went to an evening lecture with my then boyfriend. He didn't last very long, but it doesn't matter. He got me to that lecture. And a doctor from Edinburgh, a medical doctor, but not one practicing, one doing research, said that some animals could fix up their brains a lot better than we could. And if only we could understand that, then things like strokes and spinal cord injury and blindness, we might get some insights. And I thought, well, I know a bit about animals because I'm just finishing my degree. And this sounded something really exciting.
Yeah.
So I switched and just went up to him afterwards and said, can I come and do a PhD with you? And he said yes.
Simple as that.
Simple as that. So neuroscience didn't exist as a name then. You were either an anatomist, a physiologist, a pharmacologist, the list goes on, because we didn't see the brain and the nervous system and how it worked as an entity in its own right. In fact, the US was one of the first countries to catch on to that. So you had to find where you're going to live. So I worked in various departments, psychology being one of the main ones, because that really is neuroscience. And your background as a psychologist, you will appreciate that. So that's how I ended up doing a discipline that sort of evolved around me. And so that was a very lucky lecture to go to. And I say to people, if you see an opportunity, do a bit of research on it. I knew this chap was terrific. You know, it wasn't that big a jump for me. But if there is an opportunity that just pops up like that, don't let it go through to the keeper. And if you can study something or be in a job or whatever it is, which is a bit ahead of the pack, it's going to make a big difference to you. You know, so that wasn't me being brilliant. It was just stumbling almost into something that was really good.
Two quite synchronous events with the 11 plus and going to that
there
lecture.
we go.
Because I was going to ask, how do you go from biology to neuroscience?
Well,
and then I'm probably looking at it today, going, well,
if
biology would be one thing and neuroscience would be another.
So if you're a frog or a fish and the nerve that joins your eye to the brain becomes broken in an injury or something like that, it will regrow and you can see again perfectly. If it happens to us in a human, we still don't know how to get that nerve to regrow. So what is it in those animals that they have that gives that extra kick for the nerves to regrow? Or what is it in us that is a barrier that stops those nerves regrowing? And we still don't understand that fully. We know some of the barriers and we know some of the incentives to get nerves to regrow. But that was the link in for me, because this chap was actually studying fish and frogs. And, you know, I'd done a little bit about fish and frogs in a degree, so that was the link. It wasn't stronger than that.
Wow, as simple as that.
Yeah.
There you go. So, where did your career go from there? Because I'm intrigued to know, what does a career in science actually look like?
Well, yeah, that's one of the messages I try to get to young people now, is that I think you have to be flexible and adaptable. So normally you would, you finish your PhD and then you go and study, if you want to be a researcher, which I did by then, you go and get a job as what's called a postdoctoral fellow, and you go and work under some famous scientist, and you work in his or her laboratory or field site or wherever it is, in a radio telescope or whatever area you're in, and then you get more scientific papers, and then the next stage is you try and get yourself a job in a university or a research institute or in industry, you know, pharmacology industry, pharmaceutical industry, for example. Now, I didn't do that because I had to stay in Edinburgh because my husband was still doing his early stages of his medical career.
Yes.
And you did those first few years as an intern and then resident and things in the hospital, and you did it where you graduated. That was the usual pattern in those days. So I had to find a job in Edinburgh, and I couldn't see anybody who was doing the sort of work that I wanted to do. So I actually took a very routine job as a research assistant. So I had a PhD, but I was doing the job, working for the professor of psychology, doing his research. And I thought, well, that'll get me a little bit of extra experience, and it's more or less moving my career ahead a little bit, but it's fitting in with my lifestyle and my marriage. Well, he was a wonderful professor, because I said to him after a bit, I'm working for you 9 to 5, Monday to Friday, but what if I came in the evenings at weekends and tried to do my own research that I'm really interested in, and it wouldn't cost very much? Could I get going on that? And could you give me a bit of a space, you know, little corner of the lab I can do it in? And he said yes, which I thought was wonderful. A lot of people would have said no.
I was going to say, because the way you described that career before, like, you know, you go and work underneath someone famous, it's almost like, so you're going to spend quite a few years dogging it out, doing what somebody else focuses on, rather than what you truly want to do.
And it might be something you truly want to do, but how much then of the appreciation of your ideas and your creativity goes into, is made known to the rest of the scientific world. And that's why it's really important that you choose somebody who is your supervisor, who's going to give you that space in the sun and encourage you. But this was a very extreme example. Anyway, I got 3 scientific papers. I was the only author on those. And I did that all in this second job. And Richard was really busy as a doctor. He only came home 7 nights every month because he was on call and things at night.
Yes.
So it fit. We didn't have any kids then. So I then applied for money from the UK government to do my own research. Stopped doing the research assistant job. They got someone else to do that. And my little, weekends and evenings turned into my lab.
Yes.
So armed with that, and people realising I had to have done it myself because there was no other authors on the paper, it was just me.
Yes.
Then I applied for the job in Australia, Western Australia, at Uni of WA, and it suited Richard too because he was then offered a job in the Department of Medicine at UWA, and that's when we moved. So it's carving out something for yourself. Harder to do these days, I think, but with the right people and the right support.
Entrepreneurial the way.
Well, it was. I just wanted to do it. I just, looking back on it, what was I going to do in the evenings at weekends? Richard was working. Was I going to sit there and sort of stare at the TV or something? But it wasn't just filling time. It was because I desperately wanted to do this research. I was really curious. And going back to your previous question, did I think the research I was doing then would translate into clinical practice? And I didn't think that would happen. I thought it was 50 or 100 years down the track, but at least I was moving the ball sort of from one end of the court to the other, if you know what I mean.
What was the research you were doing at that point?
Well, it was what is now the very trendy word of neuroplasticity.
Oh, right.
It was showing that the brain adapted in response to experience. And that's been, I guess, my research all the way through. One of the things I did in Western Australia was to be approached by the wonderful Professor of Obstetrics and Gynecology, Professor John Newnham, and worked with him on protecting preterm babies from brain injury. Now, I never imagined I could do anything that would be clinically relevant, but I have. Other aspects of what I was talking about earlier, about finding these molecules that encourage nerves to regrow or stop them, there seem to be so many, we're still going down the list, and when there's always another barrier, you then work out what that is, work out how to mask that, but then there's the next one. So in some ways what I've been doing, it has moved the field forward but quite slowly, but in other ways, by thinking outside the box, by working with clinicians, we've had an impact clinically, and I think that's wonderful too. And in fact, it helped ensure the health of one of my own grandkids. So that's very close to home for me now.
Yes. I was interested to know, I just want to take a moment, because a lot of people, at times, science says, so then we do in science, and we talk about the scientific method. Not everybody engaged at school. Not everybody.
Absolutely.
Could we just take a moment to just run through what is the scientific methodology?
Well, I guess the scientific methodology, in its extreme form, is disproving things.
Yes.
You will know this, I'm sure, from your training in psychology.
Null hypothesis.
The null hypothesis, Popper principle. So you set up a hypothesis, which is a very swish name for a hunch. But your hypothesis has to have some sort of backing. You have to have some clues that you can apply to make it sound as if it's sensible.
Yeah.
And then you do it. And basically you try and prove or disprove that. Easier to disprove than to prove.
Yes.
But
it's like a metaphor for life.
Absolutely. Exactly the same. And some things will work and some won't. And that's one of the dilemmas of a scientist, because you can do work which is going to advance the field in little tiny edges, and we need that. I always call that percentage science. You know that if you do this study, you'll get a result, you'll publish a paper, we'll know a tiny bit more. Or do you do a leap of faith and try and jump things forward a lot?
Yes.
And there's a wonderful chap who's now president of the Academy of Science of Australia, Professor John Shine, and he ran the Garvan Institute, very famous institute in Sydney of medical research. And he said, if everything you do succeeds, you failed. And I know what he means by that, because it means if you don't every so often do something which is a little bit outside the norm, beyond, then we're not going to have those. We'll do incremental things rather than taking a leap forward. Transformational. Yeah. So it's because you want your career to grow, and I ended up with a research group of about 30 people, so my responsibility was to support them and encourage them. So you have to do some things that are going to be safe, because you want those discoveries made, but you also want to protect their career and to give them some positive feedback. I've done something important and this has made a difference.
Yes.
But then you always need those edgy things as well.
Yes.
And the edgy things are the ones, I mean, our classic example is Barry Marshall, Professor Barry Marshall and Professor Robin Warren, who won the Nobel Prize from Western Australia, on showing that stomach bugs can cause ulcers. Now that was so outside the norm. And it's interesting that if you look at the Nobel Prizes for physiology and medicine, 95% of them go to scientists who've done their work within 5 years of their highest degree. So they're the ones, the young ones, who don't know it's impossible yet and go ahead and do it anyway.
Right.
But you need that balance of the mature ones and the young bubbly ones.
Right. That's interesting that they should win that award within 5
years. That's
it.
Well, they don't get the award till a lot later, because you have to discover whether it's actually going to work or bite or be true.
Yes.
I mean, the structure of DNA was done by a young postdoc and a PhD student, Francis Crick and James Watson. So, but they got their Nobel Prize fairly quickly after that, because the structure of DNA, once people had discovered it, was, wow, this has to be right. This is, we can see so many bits of evidence that were pointing to this, but nobody saw it before, and we could apply it. But on the whole, it takes quite a long time before you get the award. But the point is, you have had that insight, you've done those studies early in your career often.
Yeah. What happens after those 5 years then?
Well, then you start running research groups, you spend a lot of time writing research grants, you teach others, you get on lots of committees, all of which you need to have the community of science.
Yes.
You need that. And then you get to my stage where you chair committees and sit on boards and write reports and mentor others and get a lot of pleasure, joy of seeing the next generation doing great things that you never imagined. Looking, if I could have taken myself in when I first came here in 1976 and 76, something like that, and see the advances we've made, I would hardly have believed it. And everybody knows that. We've got the web you didn't have before, for good or bad. We've got satellites that allow us to pick up a phone and just talk to someone around the world. Look how different a world it is now. You can get your DNA analysis done by some company, heaven knows where, but and send it back in a day or two. Think how long it took to analyse the first human genome. The first complete DNA analysis took years. Now people can do it in days.
Yes. So what is the process from somebody finding something out there in the world of science to it being, it's a pretty broad question this, but I'm going to ask it anyway, to how it actually impacts,
translates and works into
everyday life, and also,
well, shall I give you an example from me, from my life? Okay, It can take two forms, I think, at the extremes. One is, first of all, you make your discovery. You write a very short report on it, and you say, can I come along to your next conference? In my case, it'd be a neuroscience conference, and present that work. And you present it either by standing up for 10 minutes and talking to all your peers who are there, or you make a poster of it and stand next to it, and they come and talk to you about what's on it.
Right.
So that gives you feedback on, oh, did I miss anything, or is there a bit more I need to do? So you don't have to do that stage, but most people do. Plus it's advertising. I'm out there and I'm working. Yes, and you might want to give me a job, or you might want to come and work in my lab, or whatever. Or say to you, well, let's collaborate, and I can help you get your research further ahead, and I can help reciprocate. Then you write your scientific paper, and you send it, or a book, but usually a paper. And you send it off to what you hope is the appropriate journal. Now, if it's really whiz-bang fantastic stuff, you send it to a general journal such as Nature or Science, which publishes anything from archaeology to astronomy, you name it, if it's going to have a lot of impact. So, for example, going back to the discovery of DNA, that was one of the shortest papers ever published, but hugely insightful, and that was published after it was sent to the journal Nature within a week, because they looked at it. A key thing is when that paper comes into the journal, and it could be a specialist journal on neuroscience in my case, or visual science, you send it to the right, unless it's going to these really top journals. The next level of journal is one that's in your area, so that you can read all about what other people are doing on the same thing you do. Once you've sent in that paper with your results in it and arguments about what's going on and how it fits into the world, in a very standard way, aims, methods, results, discussion, and all the references, then two scientists, and you don't know who they are, two referees, are chosen by the editor of that journal, and they say what they think about it, whether it should be published or not. And sometimes they'll say, well, it could be published, but you need to do this one extra little study or something like that.
Right.
And the hardest thing is when one referee says it's absolutely brilliant and the other one doesn't like it at all, and you think, crikey, how do I keep everybody happy?
Where do I go from there?
I'll send it somewhere else. But once your paper has been reviewed, and this peer review process seems to work pretty well. Every so often something will slip through the net, but it does seem a very good way of ensuring standards. Then it's published, and people then read it. If it's something that's really exciting, it might be that the press the media want to follow it up, and there'll be an embargo, and then it'll be released a certain day, and the journos will all get in touch with you. But if it's something they're not as interested in, it'll just go through into the scientific literature. So that's what happens to most of them. The example I was giving you about working with the obstetricians, we had a real issue. We had premature babies that were being exposed to medicines when they were in utero, when the doctors had picked up the mum was at risk of preterm delivery. And to get that baby in a form that's going to give it the best chance when it's born, and that basically was to mature its lungs, you would give the mum an injection that would go across the placenta into the baby and get the lungs all primed up and ready to work if the baby was born early.
Right.
But the issue became how much of this medicine, which was discovered by a New Zealand guy, and I could tell you the story later because it's fascinating, that this particular form of therapy did mature the lung, and we knew that in one dose it was totally safe and saved millions of lives. So Montague Liggins came up with that. But we didn't know how much you needed to give during a pregnancy if the risk of giving birth early persisted a long time. Because would it get to the stage where exposing the baby to these medicines for too long could have been detrimental? And so we stepped in to work out not what the therapy should be, but how much of it we could give. Now that means it's much easier to apply it in clinical practice. Because if we had come up with a new therapy,
Yes.
then you would have had to test it for safety on normal volunteers. Then you would have tested it on people with the disease, but so ill that probably, it would, if it worked, it would be great, but the risk was less because we're trying to save lives. Through to, can you get it approved? And one of the ways you get it approved is by the FDA in the USA, the Federal Drug Administration, to say, we think this is safe and everybody can use it. But if it's a therapy that exists, what we were doing was not saying, here's a new therapy. We were saying, this is how much of that therapy you can safely use and not interfere with brain development.
Yeah.
So as we were making these discoveries, then we were reporting it at conferences, and people were listening very quickly. They were seeing our papers as soon as they were published, and they were saying, gosh, this makes sense in a clinical context. Ours was animal work. It led to 3 clinical trials around the world with mums and babies, and that confirmed what we'd found from our studies. So within 2 to 3 years, it became standard. So that was a very quick, from the initial cup of coffee to say, hey, we can do some research on this, to clinical practice influenced around the world. But that's an unusually quick story.
Right.
Does that make sense?
Yes.
Okay.
Because I'm always curious to know how, there's obviously people doing great work, but how quick does it
Quite
move
often,
from
well,
one
people
place
often
to
say
another?
from the idea to actual, in terms of developing new therapies, medical discoveries, 10 years would be, what we're looking at. Ours, as I say, was a lot more rapid than that, and that was because of this unusual set of circumstances.
And I suppose...
And some papers you'll do hardly ever get quoted, but some, for example, look at the discovery of antibiotics by Lord Florey, the discovery by Sir Alexander Fleming. He had commented on something, it was published, it didn't, it wasn't followed up by Fleming or by most of the scientific world, and then this brilliant Aussie, Lord Florey, comes along, not Lord then, but and sees the significance of it, and as a result, antibiotics were developed. So sometimes there'll be like a sleeper out there, and then somebody will say, haha, that's why it's important.
Yes.
And that's why sometimes publishing something that you don't understand the significance, and this is why the scientific method is so important, because if you have some things that don't fit in, report them too, because nature's had billions of years to get this right.
Yes.
And it's those oddities which really give you the insights, or that, that's interesting, well, I'll just report that as well as everything else, and somebody else will say, aha, that's the significance of this, I'm going to take it and work with it.
Yes.
So going back to Barry Marshall and his discovery, people said, look, the bugs can't grow in the stomach, it's too acid. He found a paper by the German scientist 100 years before who'd drawn these things because he'd seen them.
Wow.
So, often things can lie fallow for a while, but they're there.
Yes.
And you can build on them. How exciting is that?
That's fascinating.
Yeah.
When you think about all this potential knowledge that's just lying there.
Yeah, absolutely.
That could be...
Exactly, if you know what you're looking for.
Yes.
Yeah, like a detective story.
That's quite fascinating.
You can see why science and research hooks you, can't you? You can
Absolutely.
see how it would be something that so drives you. You're so fascinated by it. So an awful lot will be curiosity. But I think as you mature, you begin to see the relevance of what you're doing and how it can work. And sometimes it'll be a lot faster than others. As I say, when my team were working jointly with those from King Edward Memorial Hospital, they immediately could see the clinical significance of that. But others, they would think, well, I'm building on things for the next generation.
Yes. Yes. And how does that then move into the sphere of the public domain. And
now that's why when I became Chief Scientist of WA, the first woman to hold that role anywhere in Australia.
I was going to ask you about this role.
So that was very exciting, and I didn't actually apply for the job. They invited me to apply, which was fantastic. I had the motto, do science, translate science, communicate science. And
say that again, sorry.
Do science.
Do science.
Translate science. That means see the relevance so you can get a procedure, a product, an idea, move it across from the laboratory or the field site, wherever it is, into something that you can do something with. So it might be a discovery that would lead to a new type of therapy in a hospital, or it might be something that would design a new gizmo that you can build and set up your own startup company and make, or it could be an idea that you would sell to a company that could develop it, or give to the government and they could build it into their procedures, or give it to the community. It could be anything. But the component that scientists have not necessarily been brilliant at is communicating it. So when I started as a scientist, if you actually talked to the media, if you weren't on the TV and the radio, there was a bit of what's he or she doing that? You know, we're scientists, we're not communicators. And we have had to absolutely do a U-turn on that, because I'm totally convinced that you have to be able to communicate what you do. Because if you don't, it means that the world isn't having the greatest opportunity to take advantage of your discoveries, your ideas, and make the world a better place for everyone.
You're off working in your own little silo in Ireland.
You are otherwise. So for me, communicating is really important. It doesn't replace science, but I think any person doing a degree or a TAFE course, let's do lots after school, let's stop studying. You know, a component of that is how you talk about what you do. One of the greatest tests of that is to go into a primary school and explain it to year twos, who will soon tell you if it sounds right or wrong.
Yes.
They will be onto that absolutely bang.
In no time.
Absolutely. So you have to be able to explain. I mean, one of my other heroes is Sir David Attenborough. I've been lucky enough to meet him when he came to the museum here. He says, be simple, not simplistic.
Yes.
So don't use silly little words. Don't use acronyms. I hate them, other than DNA. I think we're allowed that one now. Everyone knows that. And maybe IT these days people know. But other than that, no acronyms. Use short sentences, simple words. If you can't explain it to a range of people, one of the ones used to be my mum, bless her, she lived to 100. If I couldn't explain what I was doing to my mum, as an intelligent person but no science training, well, there's something wrong with what I'm doing.
Yes.
And I have to be able to present it to a politician or to a captain of industry in a concise form. If they say, give me a one-pager, do that. If they want a 7-second grab, I have to be able to do that. And that's a training that I think now scientists are getting increasingly but didn't have before. And part of that is not only being in your lab with your white coat on, or on your field site, or in your hospital laboratory, or wherever you are, or in your industry complex. It's going out there and talking to all age groups, from kindergarten through to retirement villages, because one, everybody has a right to know that what you've discovered and what you think. Often, if you're a taxpayer, you've paid for it.
I was going to say, you've got dibs on it. Or...
Absolutely. One of the things I would do with my team was to say, at the end of any lecture or talk you've given to the general public, you say to them, and we worked this out, if you were the average taxpayer in Australia, how much of that research cost you as an individual for that year? How much money did you put into it? So my lab developed a second stream, which was looking at colour vision in animals, and that led to all the research about developing better wetsuits to hopefully avoid shark attacks.
Right.
I didn't know that when I started it. I did it out of interest.
Black and white stripe.
Yeah, you're right. Exactly right. So we did a lot of work on colour vision in marsupial animals, and we did it because we're Australian. We're proud of our animals. We didn't know enough about it. Hopefully it could be used in conservation projects, but basically we just wanted to know. And we worked out that the average taxpayer, it had cost them everyone 3 cents. And we would say at the end of a talk, how many people are happy that 3 cents of your money went into this research? And everybody's hand always went up.
Brilliant.
So that's what I mean by doing it. In the case of the marsupial work, I didn't think it would be translated into different wetsuits, but that's another aspect of science. You never quite know where it's going to go, but we were communicating it too. And unless you do that continuum, I don't believe any science is complete until you at least look at the potential for translation. You might not see it, but others will see it if you communicate it.
Yes. I remember when I finished my master's degree.
Yeah.
Well, not finished. When I did my master's degree in business psych back in England, and we had to go and do our dissertation study in industry, and I'd sit there in front of the MD and his directors and say, "This is what I want to do," and then they sat there and went, "That's great. So what does that actually mean?
Yes.
How's that going to affect profitability?
Yes.
How's that going to affect?"
Oh, you've
and
got
all
it.
of a sudden I was like, "Oh crap! I hadn't thought that through."
Absolutely.
I just thought if I explained it, they'd get it.
Yeah,
and
absolutely.
And it was really painful for a good lesson. Fortunately, they drilled me, but then a few of them could actually see the applicability, and they said, "Okay, Bryn, this is how we actually see it," but not before they gave me the good grilling. So
that resonates so much.
And so I was put into this painful place and then brought back out of it.
Yes.
And then it was like,
and
I think
that's all
learning
part
that
of it. It is a huge learning curve, absolutely. And it isn't something that you're taught at unis or TAFE particularly to see the applicability. But one of the things I've argued is, why not on day one of lectures to say to the students, if you have an idea or have some way that you think you can get something that you could commercialise, there's absolutely nothing wrong with that. Come and talk to us about it, share it with us, because we'll probably need our expertise to develop it, but go for it. There's nothing wrong with actually, making money out of something. You can give all the money away, or coming up with a procedure that's going to save others money. But if you have an idea, develop it. And I think we're beginning to do that now, but it's taken a while. An example I'll give is that I was visiting the Hebrew University in Jerusalem, and they have a very big medical school, and they have amazing research. The thing that is earned, or had when I visited, earned that institution most income that they could then put back into all the other basic research, was from a 5th year medical student, which was a better way to clean a stethoscope.
right.
And all the profits from that, because the student had the bright idea, he received some of the income. I don't know if it's a he or a she actually, but the rest of it came back to support much more research. So I think we need to get that idea out there even more.
Because I imagine it's an interesting balance, certainly in the scientific community. And I imagine we go through this in life. We've got our innate curiosity and passion, which can take us a long way.
Yeah.
There is also understanding, the scientific rigor of following that curiosity in a way that can then be replicable and then written up and critiqued and peer reviewed. But then at the same time, there's going to be this whole, but I've only been studying this for 9 months and I've had this idea, and these guys here have been doing it for 20 years and they've got a whole alphabet after their name. And so who am I to come up with this great idea? There's got to be this balance and tension.
And that's why I hate to say you have lots of rules and regulations, but you do need some defence so that, a student who comes up with a great new idea does get that recognition. And a classic example would be, the discovery of pulsars, an amazing lady at Cambridge Uni, who was a PhD student, and she thought they were little green men when they first saw them. Well, she didn't really think they were really, but that's the nickname they gave them because they were these very fast bursts of radio waves coming across space. Now, she didn't actually win the Nobel Prize for that. Her supervisor did. And there was a lot of feeling around the world, well, maybe the students should have shared that.
Yeah.
And so you do need a few regulations in place, I think, to set it up. And if you've been working for 20 years and you've got all the background and somebody comes up with a bright idea, sure, you've got to share it. I mean, I think that's a hugely important part of it. But often that idea will come. It can come in two ways, I guess, thinking about this, as I'm just speaking to you now. One is a discovery and you follow it on and see the implications. But the other way of looking at it is to say completely the opposite. What do I wish we could do better and differently? So I remember meeting when I was in Israel, this chap, and he had helped develop the USB, which we all now see as absolutely basic to our lives.
Yes.
I've got one in my handbag right now, just in case. And he said, and he had developed, he was a billionaire, but he was all scruffy in his T-shirt and things, because what he loved was taking an idea and finding out how to do it. And what he did was, he didn't come up with the ideas. He went to his 14-year-old son and their friends and said, what would you like to be able to do in the world we can't do now? And one of them said, well, I'd like all the information on a computer, in my pocket. And so that it can work in either way. It can be following on a discovery, or it can be saying, this is where I'd like to be, and I'm going to go back and look at all those studies that I can find that are going to give me the clues to actually then turn this into a reality.
Yes. Fascinating.
It is, isn't it? And that's why we need everyone along this spectrum, including an ability, going back to my previous comment, on scientists to be able to communicate what they know and what they've discovered so that the entrepreneurs in the world can actually say, there's the opportunity.
Yes.
And some countries are better at that than others, and I think Australia's on a big learning curve and getting better.
Where would you say the state of science is in Western Australia? Where do we sit on a global stage? I sat with Professor Bray from Curtin University last year, and he said it's never been a more exciting time to be in Western
I think
Australia.
It's hugely exciting. I think one of the other things that's changed since I popped up or joined the scientific world is that now you need much bigger teams to do things, because you will do, for example, going back to the biological scene, I mean, if we wanted to discover whether an animal could see a particular colour, let's say we want to see if quokkas could see red, well, you could do anything from look in the genes to see if the gene was there to produce the right chemicals that would be in that system to make colour vision work, or you could get an animal and put it in a little test situation and see if it responded to different colours and got a reward. Or you could use a special machine that we didn't have at first, but I managed to get one, called a microspectrophotometer, where you look inside individual cells. What I'm trying to say is there's usually a range of things you can do in any study.
Yes. And
this needs a range of skills. So if you want to look, for example, at the DNA to see whether it's in there that this animal could possibly see colour, then you need bioinformaticians, they're now called, sort of statistics people who can analyse what's in there, because the DNA is so huge, right through to me writing to the zoo and saying, can I come and watch your animals, or could I go in a rot nest and watch them in the wild? So you need much bigger teams on the whole now to do things, and that's good because it gives you a better result and faster, and you feel you have more confidence in it. And it also brings you in contact with more and interesting people to sort of get different insights into things. But it does mean that because the world now can communicate very easily, WA can take advantage of what we're good at without being isolated. So I can have an idea and I can be talking to someone in Russia or in Canada about it, in a second. And the things, so I believe we have to be good at two things. We have to be good at what we really have the potential to do well. We have great biodiversity. We don't understand that fully yet. There's probably all sorts of molecules in our plants, for example, that could have lots of health benefits.
Yeah.
But we also need to know what's in our oceans to protect them. You know, we need to understand a lot more about the ocean currents, not only for our weather, but for our fishing industry. So these will be the sort of medicine. We've been very strong in medicine. If you want good hospitals with the best doctors, nurses, you have to have the best research going there, because that's where those people will go. So there are lots of examples where we can lead the world. We lead the world in automated mine sites.
Yes.
There is no doubt about that. As I say, we won a Nobel Prize through Barry Marshall. So these are our strengths, but there are things we need to be good at. And one of the things about Western Australia is it's a very big place. So one of the potentials we have is to say, right, we can make telemedicine, for example, work really well. So my husband actually does this. He will.
What's telemedicine?
Telemedicine is where your consultant is sitting in a teaching hospital in Perth by default, and your patient, your client, is in Kununurra, Esperance, a remote mine site on an Aboriginal reserve, and you're actually working with the local clinical community there. So these are things that we can develop a lot more and share them with the world, because again, there are so many people who could benefit from that.
Yes.
So and lithium would be another example. Lithium isn't found in many places around the world, but it's essential for your mobile phone and all these modern computer systems. Well, can we develop, and we are, looking at lithium mining becoming an important part of our economy.
Yes.
So we have to look at where we have strengths and where we have potential strengths, but also where we have needs. And if you put those together, there'll be some things that we won't do. We won't do response of people to living at higher altitudes, because we haven't got any really high altitudes, but we do have deep oceans.
Yes.
So
and we have got like lots of space. Like
absolutely. So it's looking at those, and it's also looking at the individuals who have fantastic skill sets, who choose to be here or we can attract here. So one of the other world leaders who was the Scientist of the Year for WA last year is Professor Peter Newman from Curtin Uni. He's a world expert, in no doubt at all, on sustainable cities. Well, boy, let's make the most of his knowledge from around the world to move in that direction, because we all want a more sustainable life.
Yes.
So that's the way I interpreted the needs of science, technology and engineering when I was chief scientist, and I'm sure that's the way the wonderful current chief scientist for WA, Professor Peter Clinton, is doing.
Yes.
And encouraging all our young people, because we need the next generation.
Was having a large amount of space a key part in the Square Kilometre Array?
Absolutely, and you're so right to mention that. Potentially the largest science undertaking on the planet ever needs an array of radio telescopes in somewhere that's really radio quiet. So go up to the Murchison, where there's about 130 people in that shire, 100 if they all nip into Geraldton to do their shopping, where we can listen into space without interference from mobile phones, microwave ovens, your camera, you name it. And so between Western Australia and our friends and colleagues in South Africa, their facilities in the Kuru Desert and ours is in the Murchison, we are busy building the biggest array of radio telescopes the world will ever see. And it's called the Square Kilometre Array because if you count up the area of all the dishes put together, if they were all in one space, they would occupy 1 square kilometre. It's huge. But it's even better to have them distributed a bit, as we discovered last week with the first photo of a black hole. How awesome was that? And that worked because we had telescopes in 8 locations, from Antarctica through to Chile, through to North America and through to Hawaii, that could piece together bits of all looking at the same thing at exactly the same time. And that's another strength in WA, because we've helped develop the most accurate clocks in the world, so that we all looked at the identical fraction of a second, and took the photo from slightly different angles, because it's like having the whole Earth looking, and then we could see a black hole that I guess we almost thought we had seen before, because we'd seen so many computer simulations, but we had never seen it, and there it is.
Yes.
I mean, how exciting is that? And people say to me, well, why is Einstein important? Well, Einstein's important because, and certainly seeing this black hole is further confirmation of his amazing insights. Without that, you wouldn't be listening on your mobile phone, your GPS wouldn't be working accurately. We need all this, and we use it every day. But Einstein didn't realise that, because at that point we didn't have satellites in space, and we certainly didn't have mobile phones.
So what are you working on now?
Oh, I've got several projects I'm really interested in. One is helping young people on the autism spectrum, not a disorder. We're all on spectra for something, particularly those who have a lot of IT skills, to get extra support in school, to get them through uni and TAFE, and to get them into employment. And we're having huge success at that, because they're really good at it. So that's one of the things I'm very involved with. It's called the Australian Academy for Software Quality Assurance. It's based at Curtin Uni. It's a big mouthful, but AASQA. We know that somewhere between 1 in 70 and 1 in 100 children are being diagnosed as on the autism spectrum. So it's a very big need, but a huge opportunity. So that's one of the things I'm very involved with. I'm also very involved in a program called Financial Toolbox, which I helped establish after I was the West Australian of the Year in 2015 and met Rosie Batty, and said to Rosie, because she won that year, and didn't she need to, it was wonderful, what could I do back in WA to help address the awful issue of domestic violence? And she said, if you could get people more skills in their finances, it would help. So a month ago, we launched Your Toolkit. So go on to www.yourtoolkit or www.financial toolbox, and you'll find it. And it's a guide for what you do if you are in a situation you need to deal with, so that what to do re your finances when you're in that situation before you leave, or perhaps means you wouldn't have to leave, as you leave, immediately after, and long term, because we know that domestic violence is horridly common. It affects both men and women, although women more. And if your partner, for example, changes the passwords, stops you getting access to your credit card, worse than this, lands all his or her debts on you, then you really need some help in sorting that out.
Yes.
So that's one of the other things that I'm spending a lot of time doing. Visiting schools. I'm patron of a school in Mandurah, love doing that. So I'm also chair of the Medical Research Foundation of Royal Perth Hospital, where Barry Marshall did all his work, to support those young scientists and doctors, and the mature ones, to make sure that they're doing wonderful research, which they are. And going back to the translation conversation, some of those are making a huge difference already. An example being these ghastly episodes where somebody gets a one-hit punch, you fall, you crack open your skull, you need the bone to be rebuilt, and we now know how to do that at Royal Perth with a wonderful program of putting together biologists and engineers and working with clinical doctors, going back to the team approach. So we can give you a ceramic scaffold through which stem cells, your own stem cells, will grow and rebuild that bone to protect you. How awesome is that? So those are three. I've got a much longer list, but they're three that come to mind immediately that I'm doing right now.
Yeah. Certainly with the autism and the toolbox, what are some of the things from your life as a scientist that you've brought into those?
Teams. Getting teams together, because science is teamwork, as I've said already. Finding enthusiastic people you can rely on. getting a range of skills. It's just like science. You need you need probably somebody with accounting skills, a lawyer in this case of our toolbox, someone with IT skills, becoming more organised with time so that we now have working groups, call them subcommittees, whatever you like, to work with the rural community, to work with young people, particularly the women at risk, but we also organise workshops just for everyone to learn better financial planning, because it's not something you learn particularly in school these days. They're beginning to introduce it, but gosh, you need to know these things. So yeah, the same principles that have worked for me, and how you communicate it, so that when you get half an hour to sit down with the Minister for Women's Interests, which we did, and thank you the state government for funding your toolkit programme, we had to get that message across simply and clearly. We had to tell her it was a good idea, how we were going to do it, and why it would work. And it's interesting because speaking to the Minister afterwards, the Honourable Simone McGurk, she said, people come to me with ideas, but they don't tell me how they can make it work.
Yes.
So, it's whether you're running a science team or a program like that, which seems a bit different. I'm the sort of rover out there. I'm there talking to community groups, talking to you now, getting us on the radio, so that both Channel 7 and the ABC have run slots about us to get the message out there. So I do that sort of much more entrepreneurial role, and coming up with ideas, so that basically, when we set this up, we said we can just run a series of workshops or sort of events where we get key people to talk about women in leadership, but we want to do something practical, and this is the practical thing, where it took nearly 2 years of research to come up with it. Going out, talking to women at risk, seeing what they needed. Again, that's like science. You do your
stand up,
you investigate the idea, you see if it's got legs, and then you start putting it into practice. It's very similar principles, and it's the same running anything, running your house, running a scout group, anything.
Do you miss having a little corner in a laboratory?
No, not for a moment. I think I'd be positively dangerous. And I've got to the stage now where I just enjoy hearing the brilliant things that other people have done. And I guess because I love everything. I love the sky. I love animals and plants around me. I love seeing medical research working better. I love seeing young people who wouldn't have a job now in a job. It's just, for me, I'm so lucky that I can do all these things. And for example, the opportunity to talk to you and just share some ideas. Hopefully someone listening to this will be inspired to do something they wouldn't have done before. Go for it.
What have you learnt about yourself on this journey?
Well, I'm still trying to be more confident. I think the imposter syndrome, thinking, could this be me? Can I do it? Is it going to be okay?
Do you mind if I ask?
Is
that
still
an
have
English
that.
thing?
I don't know. I don't think so. I come across it around the world. But I think in a way it's not bad, because it means you don't jump in and think you can be all things to all people. You have to be in teams. You have to like everyone in the team. There's nothing worse than a team where somebody really annoys you. I'm too old to put up with that anymore. I've always known that once I'd found my partner in life, that relationship and my family were always first. Because if you haven't got that, what do you have? I've been incredibly lucky that way. I mean, I looked after one of my gorgeous grandchildren yesterday, and we made a cake we never made before, and I used plain flour because the recipe said it, and I should have used self-raising, but nevertheless it was a bit thin, but it tastes good. So yeah, that's always the first consideration. And then I love the idea that at the end of the day, I feel I've done something that's, I know it sounds corny, but it's helping make the planet a slightly better place. I mean, before I came to see you, I met with this lovely lady that I'm mentoring. She's a student aged 21. I met her when she was 19. She wants to be an astrobiologist. She wants to understand about life in space, life forms and molecules that make it and things like that. And I introduced her to a fantastic team at Curtin University. She's publishing her first paper now, would you believe it? She's still an undergraduate. And she said, without that one meeting, I'd never be doing any of this. And it's completely changed. It's given my life a direction. I know what I want to do with my life. I mean, what an honour for me to do that. And then to come and talk to you. And then I'm meeting with someone later today who wants to be more involved in getting into schools to share the message of science. So, by the end of today...
You'll have made an impact.
I hope I've stopped it going backwards at least.
Indeed. What does the next sort of 3 to 5 years look like for you?
Well, on personal terms, the bucket list. We did Antarctica. We've done some A's. We've done Alaska, Antarctica, Atacama Desert. So I don't know when we get onto the B's. From that personal point of view, watching my grandchildren grow up. They range in age from 16 down to 1. Being there, supportive for them in as many ways as I can. In terms of initiatives, I'm not very good at saying no to things, so I've got so many things that I'm doing that basically I suppose you could put into 2 categories. It's helping in the sort of social, medical sort of researchy area, and it's working in the environmental area. I haven't talked about that much, but that's very close to my heart as well. So I chair a national committee called Terrestrial Ecosystems Research Network to monitor the effect of climate change on our environment. And I'm very involved with turtle research now. So I guess the next 5 years we'll see if people still want me to be doing things, because I don't want to push, I only want to be useful as long as I'm useful.
Yes.
But I'm lucky enough that people are still inviting me to do things, and I'm not the sort of person to sit around and just watch the world go by. And I don't have... Somebody said you don't have any hobbies. Well, cooking's my hobby, actually. I cook at least one new recipe every week, and I love cooking. But I don't have lots of other things. I'm not in the tennis club and things like that, because I'm still, luckily, have a full diary, as you know, for finding a spot for us to do this together.
Yes.
So aren't I lucky?
Yeah.
I'm incredibly lucky. I know. No wonder I've got a big smile on my face.
You do. You do. One of the last questions
I'm going to the gym. I have to go to the gym 5 days a week. But it's usually 4. Let's admit it.
Let's admit it. Keep your body maintained.
Absolutely.
One of the last
don't
questions,
do that.
One of the last questions I ask my guests is if you could upload just a nugget of information into the collective consciousness, just so everybody gets it, what would that be?
Go for it.
Go for it.
Absolutely. And have confidence in yourself, and get wonderful people around you to support that. And everyone, I had a wonderful quote from a gorgeous Aboriginal lady, a grandma, who was helping at Narrogin Senior High School, and she said, "It's not how smart you are, it's how you're smart. Because every single person has talents. It's just finding those talents and encouraging them." And so I absolutely think that everyone has something to give in whatever way it is, and just try and do that. So it's not how smart you are, it's how you're smart, because we are all smart at something.
Awesome.
That's more than one sentence. Sorry about that.
No worries. Lyn, it's been an absolute pleasure to talk to you today and listen to your journey. I'm just overwhelmed by...
Don't be.
It's just lovely to hear. and to sit and see you smile as you talk about it as well, and how grateful you are for it all.
I am, absolutely.
Thank you very much for your time.
Thank you so much. I've really enjoyed it and appreciated it.